Welcome guys to another video. So yeah, sorry for not uploading for like 2 days. I couldn't record and couldn't come up with any ideas basically. So yeah, this is another problem. Okay, I forgot to write the 1 year. Yeah, this is another problem from Stanford Math Tournament, General Set 2011. So this is an interesting problem. This is I think this is the second take. In my first take, I was doing stuff. But then I realized, oh man, I'm dumb. I can't do anything. I can't factorize and stuff. So I stopped recording and I deleted it. Yeah, so anyways, it's an intriguing one. You'll know when you know, yeah. So, okay, so first of all, the question itself says that, okay, we have a equation, absolute value of x minus 1 times absolute value of x squared minus 2 is equal to 0. And we have to find the rational roots. Okay, so first we start by, okay, we say that this part is say greater than 0, x squared minus 2 greater than 0, which implies x squared greater than 2 implies x squared greater than square root of 2. And if x squared is greater than square root of 2, and square root of 2 is of course more than 1, we can say that even this one is positive, so we can just write them as it is. So without the absolute value sign. Okay, and we have an x squared minus 2 is 0. Okay, so far so good, right? So we have an x cubed minus 2x minus x squared plus 2 minus 2. Now these two cancel out, and you'll see why that's important. Yeah, so we have our cubic equation. It's 2x. Wait, is that? Okay, yeah, it's correct, I think. Yeah, so that's nice. Okay, so let's see. Let's first factor out an x, right? You have x squared minus x minus 2. This is all equal to 0. Now, okay, so for this part, we can split the middle term. So I think we can take a plus 1 and a minus 2. Yeah? Wait. Yeah, plus 1 and a minus 2. So we have x squared plus 1x minus 2x minus 2. And this is equal to 0. Okay, good enough, good enough. And of course, if you don't understand the splitting the middle term part, just comment down below. If it's like too hard for you to understand, I might just find a few problems and make a video about it. So yeah, x times, okay, so this is easy enough to factor. Well, okay. Man, I'm running out of ink. Yeah, I never thought this day would come, but it has. So okay, so we have an x plus 1 there, right? If you factor out an x, that's easy enough to see. And if you factor out a minus 2 from here, it's x plus 1 again. This is equal to 0. Okay, so we have x minus 2 times x plus 1. This is all equal to 0. And from here we get 3 rational roots. One of them is 0, one of them is positive 2, and one of them is negative 1. So we have x equals 0, 2, and minus 1. Right? So far so good. Okay, that's one of the part, right? And you'd think we need, yeah, then of course more intervals to look at. So let's look at this part again, but it's less than 0. So okay, x squared yeah, x okay, y. Yeah, I'm just gonna take another pen, dude. This is annoying. High quality content. Yeah, I'm gonna get new ones. Okay. Yeah, so okay, so now we assume that this is less than 0. So x squared minus 2 is less than 0, x squared is less than 2, x is less than square root of 2, and because x is less than square root of 2, right? So first of all, okay, So firstly, we'll just assume that x is also greater than 1. 1, right? Yeah, for now. Just so that we can just write this as it is, okay. And I just want to make a point, right? And now, of course, because it is this is negative, so it just flips around. So we get 2 minus x squared minus 2 is equal to 0, right? Okay, so I am multiplying these out. It shouldn't be that tough. So we get 2x minus x cubed minus 2 plus x squared minus 2. This is all equal to 0, right? Now, okay, let me just rearrange this for you and combine these two parts. X cubed plus x squared plus 2x minus 4 is equal to 0. Okay, and now this is the part where I started to it started to sink in that, man, I can't factorize this. Yeah, so I was like, just try factoring it, right? So by the rational roots theorem, okay, so we know that all the possible roots are the product of the last and the first, all the rational possible roots. So yeah, they can, yeah, so we have plus or minus 4, plus or minus 2, and I think plus or minus 1. Yeah, that makes sense, hopefully. Okay, so, well, let's quickly check, right? So for 4, well, I don't really want to check, but okay. Yeah, so for plus 4, well, let's mentally check. Okay, so we have 64 plus 16 plus, yeah, okay, that's surely going to be not 0. Let's check for minus 4. Okay, perhaps that would work. Wait, oh yeah, there's a minus x cube. Okay, well, minus 64, I guess, for the first one again. Yeah, I forgot to put the minus sign there. Noob. Okay, so we have a minus 64 for plus 4. Minus 64 plus 16. Yeah, that's 48. Plus 4 minus 4. That's not 0. Well, let's take a minus 64, which is a 64 plus 16. That's 80 minus 4. No, wait, minus 8 is 4. Yeah, minus 8 minus 4. But that's still not 0. Now for the 2's, I leave it as an exercise for the viewer. But yep, classic. Nah, it's easy enough to see that, none of these are roots for it. None of these. Which implies that this cubic has no rational. That's. I mean, it may have real roots, but no rational ones. So, no rational. I think that's, I'm pretty sure that's the symbol for rational numbers. Roots. Man, and that really got me. So yeah, I think it's safe to say that these three are the solution. So the final solution, final answer, we have x is equal to either 0 or 2 or minus 1. Yeah, so that's pretty much it. Just watch out for such equations. Don't let these get your morale down. Yeah. I was in depression for like 2 seconds. But yeah, this doesn't have any rational roots. That's pretty good. So, yeah. Just watch out for such equations, man. It really got me. Yeah. But yeah, overall discussion it's nice. It doesn't make you factorize cubics and stuff. Just let you use your brain. Nice.